This is organizing quantitative data, the popular displays. And the first item is a histogram. This is constructed by drawing rectangles for each class of data. The height of each rectangle is the frequency or relative frequency of the class. The width of each rectangle is the same, and the same, and the rectangles touch each other. There we go. Now we've got a frequency distribution. This lists data values either individually or by groups of intervals, along with their corresponding frequencies or counts. It can be displayed in a bar chart. Show this. Maybe I have ages. And that goes from 0, 5, 10, 15. And this goes to 4. And this one goes to 9. This one goes to 14. And this one goes to 19. Then we have frequency. There's 5 in this range, 2 in this range, 12 in this range, and 3 in this range. That's an example of frequency distribution. Now we can also display that with a histogram, constructed by drawing rectangles for each class data, and we'll see more of this in a little bit. Now, just like before, where we had a frequency distribution, you can have a relative frequency. Now, with the relative frequency, you're going to sum these together. 5 plus 7, 5 plus 2 is 7, plus 12 is 19, then 22. Then for our relative frequency, we'll take each one of these frequencies, divided by that total, and then multiply it times 100. So this one will be 2 divided by 22 times 100. This one will be 12 divided by 22 times 100. And this will be 33 divided by 22 times 100. Now let me do this. 5 divided by 22 times 100. And I'll round it to, I don't know, 1 decimal place. 22.7%. 2 divided by 22 times 100. 9 into 1 decimal place would be 9.1%. And then 12 divided by 22 times 100 would give us 54.5%. 3 divided by 22 times 100 would give us 13.6%. Now, typically, you like these to add up to 100%. You know, like this is 0.7 plus 1 is 0.8. That gives us 14, 19. So I'd do the 9, carry the 1. So I really want one of these to be greater, like 13.7%. Now, technically, we'll leave it this way. But if you're in a workplace, well, somebody, when you take this to a meeting, they'll sit there and add these together. And they'll, well, where's the missing 0.1%? It's just like, it's rounding. Leave me alone. But they'll do that. So now, we'll also have something called cumulative frequency. So let's go ahead and talk about that now. Cumulative frequency, it adds up that current frequency plus all the ones above it. So this one's 5. This one's 2 plus all the ones above it, which is 5. So that gives us 7. Then this one's 12 plus all the ones above it, so 2 plus 5. That gives us, 19? And then the last frequency, which is 3 plus 12 plus 2 plus 5. And that gives us 22. So that's your cumulative frequency. Now you can also have your cumulative relative frequency. Where you add up all the relative frequencies plus all the ones above it. So this one's 22.7%. This next one will be 9.1 plus 22.7%. And I'm not very good at decimals, but let's see, that's 0.8, 1, 31, 31.8%. Let me add it up in my calculator. 9.1 plus. Been a long day. I've been creating videos all day. Then our next one, we'll add up the current percent plus all the ones above it. Now, all the ones above it would be this one plus this one, which we already got is 31.8. So to save space, I'll add up the 31.8 because that's already the ones above it. Okay, so 54.5 plus 31.8 gives us 86.3. And again, in theory, if I take this, the current percent, and all the ones above it, that should be the 86.3%, which should give us 100%. Which ours gives us 99.9% because of rounding. But that's a cumulative relative frequency if any of the problems are referring to that. So that's how you get all of your different frequencies. Let's see, just to briefly show that in Excel. Okay, so if I have my ages here. Now to get, I'm going to put a single quote, otherwise it'll think it's a numerical measure. And just as soon as I find my 0 to 4, so do 0-4, and then 5-9. We're going to see that there's a reason why you'd want to even separate these in separate columns, but I won't do it yet. 10 to 14, and 15 to 19. Okay, so we got our frequency here, and we got 5, 2, 12, 3. Okay, so let's find our relative frequency. Well, for the relative frequency, I need to add these together. So I'm going to click down in this cell here. I want my home tab, and then I want to click the auto sum. And it'll guess what you want to do the sum on, and that's fine. B2 through B5 is what I'm wanting. So I click this check mark here or press enter. Now for relative frequency here, I'm going to do equals, and I'll do B2, because that's where that number is, the number 5, divided by, and I want to divide by B6. But specifically, I'm going to put a $B, $6 around that, then times 100. We'll talk more about that later, but for now, that's our formula. Okay. So now if I click this cell I just created, put my mouse in the lower right-hand corner till it becomes a plus, click my left mouse button and hold down and drag it down, then it'll build those. And I see I got 22.7, 9.1, 54.5, 13.6. So the same values. Now if I look at each individual formula here, you notice this says B3, which is this cell, divided by B6. Let me press escape to get out of that. Let me click this one, click in here, B4 divided by B6. Now, so as I filled it down, it'll adjust itself based upon what row it's in. But by putting the dollar signs before the B and dollar sign before the 6, that'll hard code it so it'll always point to this, no matter how much I fill it down. Okay, our cumulative frequency. I'm going to do an equals. And it's the current frequency plus all the ones above it. So I can do 5 here. This one I can do, and if I don't want to hard code it, by the way, I do equals B2. Now point to the 5. This one I'll do an equals B3 plus B2. So it'll add the current frequency plus all the ones above it. This one I'll do equals B4 plus B3 plus B2. The current one plus all the ones above it. Now there's a very quick way to do this, but and then equals, and then B5, plus B4 plus B3 plus B2. Now I specifically show this so you can see the exact formula for cumulative frequency. Now press enter. Okay, so now if I'm wanting cumulative relative frequency. I'll add the current percent plus all the ones above it. So this one's be C2. This one will be C3 plus C2. So I'm adding the current relative frequency plus all the ones above it. This will be equals C4 plus C3 plus C2. Current relative frequency plus all the ones above it. And the last one will be C5 plus C4 plus C3 plus C2. And that'll give me my 100% there. Now notice I didn't have any kind of rounding issues here because I'm in Excel and it keeps all the decimal places for me. But that's how you build all of your different frequencies via Excel. Now it also says the frequency distribution, besides listing the data values along with the corresponding frequencies, can be displayed in a bar chart. And we'll see more of that here in a little bit. Now we got something called our lower class limit. This is the smallest numbers that can belong to the different classes. So let's take a look at this. My lower class limits, LCLs, and my upper class limits, UCLs. So for my example above, my LCLs would be 0, 5, 10, and 15. My upper class limits would be 4, 9, 14, and 19. Like that. And actually I meant to draw it over here, but I need my pen to work. There it goes. Okay, so my LCLs and my UCLs. So what was it? 0, 5, 10, and 15. And there are benefits to listing these separately. That's 4, 9. Now you notice this went from 0 to 5 to 10. It's increasing by 5s, isn't it? So over here it'll increase by 5. So I don't even need to go and look. 4 plus 5 is 9. 9 plus 5 is 14. 14 plus 5 is 19. That's called class width. So on this one, our class width is equal to 5. Okay. Well, if I can get back there, there's my PowerPoint. So lower class limits, upper class limits. I guess I ought to actually put that on there. There we go. Now we got open-ended distributions. This is the first class has no lower class limit, or the last class has no upper class limit. So maybe you want just greater than 15. Maybe there's so many oddball characters out here past 15 that to list them all would be ridiculous. So we just do greater than 15. Now typically this is the way your classes go, from smallest to largest. Now that isn't written in stone. You could go from largest to smallest, but this way I think actually makes more sense. Now we have gap. This is the difference between the lower class limit of one class and the upper class limit of the class right above it or below it, depending upon data being ascending or descending. Here, our gap is the difference between where this one ends and this one begins. So this goes from 4 to 5, so that's a gap of 1. Then you got half the gap. This is multiply the gap by 0.5. So half the gap. 0.5 times 1 gives us 0.5. Okay, we got an upper class boundary, UCB, and we also got a lower class boundary, LCB. And I ought to reverse these actually, like there. Okay, so let's take a look at our lower class boundary and our upper class boundary. With our upper class boundary, we add half the gap. So our half the gap is 0.5, so this would be 4.5. Now this would be 9.5, we're adding half the gap. But the fact that I know the class width is 5, I can easily come up with it. 4.5 plus 5 is 9.5, plus another 5 gives us 14.5, plus another 5 gives us 19.5. Now over here, lower class boundary, we subtract half the gap. So 5 minus 0.5 gives us 4.5. And add 5, that'd give me 9.5. 14.5. And you probably see a pattern here, right? This one ends in 4.5. This one begins in 4.5. This ends in 9.5. This begins in 9.5. Now, going backwards, I'm going to subtract 0.5. So this would be negative 0.5. And that's what we're saying here. Lower class boundary is lower class limit minus half the gap. Upper class boundary is upper class limit plus half the gap. Now this, these ranges over here. Well, if your value is 4.2, it's not in any one of these classes. That's the problem with it. But if we include the boundaries, then you see how this encompasses all of our values. Now there is a problem with that. If your value is 4.5, where does it fall? Does it fall here or fall here? Well, the places we use the boundaries at really doesn't matter. One of the places is where we have charts, bar graphs, like this. And you see how where one ends, the other one begins. So 4.5 actually is in both places if we look at a bar graph, where the bars are right together. Okay. Next one is the class midpoint. Well, our class midpoint is the lower class limit plus the next lower class limit divided by 2. So we got 0 plus 5 divided by 2, and that gives us 2.5. Next one would be 5 plus 10 divided by 2. That's 15 divided by 2, which is 7.5. Notice how I went from 2.5 to 7.5, so I can keep adding 5, the class width, over and over to get the rest. So this is 12.5. And this would be 17.5. Now this is what we talked about class width. The difference between two consecutive lower class limits or boundaries, or two consecutive upper class limits or boundaries. Excuse me. This one from 0 to 5, 5 to 10. See how they're all increasing by 5? So it doesn't matter which one you look at. That's your class width. Okay, constructing a frequency distribution. And this is just kind of a general guideline. It says decide on a number of classes, n, and this will be between 5 and 20. It doesn't do you any good to have one class and have everybody fall into that. For example, let's say I come up with hours watching TV per week. And let's see, this would be 0 to 20. And this one would be 21. Now see how this went from 0 to 21? I'm adding 21, aren't I? That's class width. So I add 21 here, and that would give me 41. Okay, and then I have my frequency. Now here I just have two classes, and let's say 50 people fall here, one person falls here. You notice how it's too bunched up here? We have no clue of the real breakdown because we had too few classes. Now if you have too many, then it won't mean anything. Like over here, if I have hours, and there's 1, 2, 3, 4, 5, and so forth, and then if my frequency, here's 1, 1, 1, 2, 1, the class width is so little that we can't see any kind of pattern. So it's usually between 5 and 20. Second one, calculate the class width. Highest value minus lowest value, then divide by n. And round up to a convenient number. When I say round up to a convenient number, adding by 5s is pretty easy. Now adding by 21s isn't so easy. So if you come up with, after you've done that calculation, you come up with 3.17. Well, I could definitely take it up to 4. Or maybe if you just want to add 5s, 5 would be better. It's not a real precise procedure. You just kind of tweak it as you go on. Now 3, choose the lower class limit for the beginning class using the lowest data value or a convenient number. Let me grab a drink here. Okay. And then keep adding class width over and over to get other LCLs of other classes. Figure UCL from these, usually a gap of 1 or 0.1 or 0.01 assumed. For example, if you have one decimal place in your data, then use 0.1, since it has one decimal. Then go through your data and put tally marks in an appropriate class and add them all at the end. Let's give you an idea. How would you do this? By hand, which isn't a good way. Okay, so I got 70, 80, 85, 95, 100, 60, 62, 75, 83, 91. And we want to build a distribution. Decide on a number of classes. Let's say n is equal to 5. Okay, or small, toward the small end. Calculate the class width. Highest value minus the lowest value, then divide by n. So highest value is 100 minus my lowest value, which would be 60, I guess. Divide by n. This one comes out too nice, but that's 40 divided by 5, which is 8. It's not that hard to add 8 over and over, so I could probably live with that. If I don't want to do 8, go up to 10. Maybe that'd be better. Go to 10. Sometimes you don't know when you're doing it by hand until you actually get started. Okay. Choose a LCL for the beginning class using lowest data value or a convenient number. Our lowest data class is 60. So let me see. These are my values. So I'll start at 60 here. That's my first lower class limit. Keep adding class width over and over to get the other LCLs. So my class width is 10. So this would be 70, 80, 90, and 100. Now there is no decimal places in this, so I'm going to assume a gap of 1. So this starts at 70. This one will end at 69. And if my class width is 10, then this will be 79, 89, 99, and 109. That was step 5. Then step 6. Go through and put tally marks. Okay, my first data point 70, that'd fall here. Then 80 would fall here. 85 would fall here. 95 would fall here. 100 would fall here. 60 would fall here. 62 would fall here. 75 fall here. 83 would fall here. 91 would fall here. So then our frequency, this will be 2, 2, 3, 2, 1. So that shows our breakdown. So these are our classes, and then these frequencies that go along with it. Again, this is not set in stone. Maybe 8 would have been better to go by instead of 10. Sometimes you don't really know until after you've created it, and as you're looking at it, it's like, that's not quite what I was wanting to look at. So then you tweak it. Maybe make it about 5s. Okay, relative frequency distribution we've talked about. Replace frequency with the following formula. Class frequency divided by the sum of all frequencies. We did that at the very beginning here. And cumulative frequency we talked about. Let's take a look at creating a histogram using technology. A little bit easier than the way we've been doing it. Okay. We'll use our data points here. They're not very exciting, but they'll work. Okay, so our steps say put data in column A. And it says, let's say it is in A1 through A25. Ours won't be, but I get there. Here it is. Okay, 70, 85, or 80, 85, 95, 100, 95, 100, 60, 62, 75, 83, and 91. So ours is an A1 through A10. It then says, put your upper class limits, your bins, in the column B. And let me see. Ours was if I went with that same data I just created, ours was 109, 99, 89, 79, 69. So those are upper class limits. Well, to create this histogram, you first have to choose your file. You come down here to your options, then choose add-ins. And when this comes up, you choose Manage Excel Add-ins. You click the Go button there. And you want to choose the first two, Analysis Toolpack, Analysis Toolpack VBA. So you check them, and then click OK. And under the Data tab, you'll have an option here, Data Analysis. So then it says, okay, click Data tab, Data Analysis. We actually got one that says Histogram here. This is on every version of Excel. So you click Histogram and click OK. Now for our input range, this is where we put it in column A. So in our case, we'll have A1 colon A10. And our bin range. Bin is upper class limits, which was in B1 through B5. Now I actually went in one example, went from smallest to largest, and it works. They don't have to be in any certain order. Now down here, if you choose chart output, and then click OK, this will give you our frequency distribution. It also gives you the histogram, the bar graph, like that. Now, people may not be used to what you see here. See how this is only your upper class limits? Well, if you know that your gap is 1, the first one ends at 69, and next one starts at 70. So this would be 70 through 79. Then this one would be 80 through 89, 90 through 99, 100 through 109. And going backwards, knowing our class width is 10, this would be 60 to 69. And then your frequency is going to be 2, 2, 3, 2, 1. This is what more people are used to seeing. They're not used to the bin values you see there. Very quick way to get a histogram. Now, that's these steps right here. Let's say I want to just create a histogram, and I don't want to think that hard on it. I don't want to put the upper class limits in there. So let me delete those. All I got is these. Well, if I choose my Data tab, choose Data Analysis, choose Histogram, and click OK, I'm going to get rid of the bin range, blank those out, and up here we want to put in A1 colon A10. Chart output selected, and click OK. Now it'll pick what it thinks the best bin values are, which may or may not be what you want. But if you want it very quick and dirty to create the data, then that's how you do it. And I show you examples here of the values you can set, for the input range, for the bin range. Chart output, usually you want to select. Now we can also create a histogram on our graphing calculator. So let's follow these steps. Okay, so this says put data into L1. So I'm going to press my Stat button. I do enter on edit. And our data was 70. So 70, enter. 80, enter. 85, enter. 95, enter. 100, enter. 60, enter. 62, enter. 75, enter. 83, enter. 91, enter. Then it says, okay, Stat button, edit. Then we're going to do a second y equals. And actually, before I do that, I'm going to press y equals. If you got something left over from algebra, go ahead and press your clear to clear that out. Okay, now we'll do a second y equals. Then it says choose on, or then enter on plot 1. So go ahead and press enter on plot 1. And we want to choose on the third graph type, L1 and 1. So the on, my flashing cursor is on, so I go ahead and press enter one time. Down arrow to type, and it says choose the third graph type. Well, that's one that looks like the bar graph, or histogram. So I'm going to right arrow over, put my flashing cursor on a little bar graph, and press enter. And then it says L1 and 1. Well, it should already be set to L1 and 1. If it isn't, you can down arrow to this and do second and then 1, put L1 there. And frequency should always just be the number 1. Now, unfortunately, when you come down here, it's in alpha mode. So you would have to press your alpha key one time and then press your 1 if it wasn't 1 wasn't already there. Okay. Then it tells us to press the window button. So press the window. That's weird. Okay, I'm going to exit out. And let me press mode. And if you got one of the newer TI-84s, if you want your buttons to look like mine, down here at the very bottom on the second page, see where it says Stat Diagnostics? Oh, that is off. I guess it's just going to be a little bit different no matter what on the new one. But anyway, under a second y equals, I'm in here. Once you get done with that, you do a second mode exit out, I guess. Then press my window. Okay, then it says X-min is the lower class limit of the first class. So a lower class limit. Well, we actually started ours at 60, didn't we? So let's go ahead and choose 60. First lower class limit. Then the X max is the lower class limit of the class beyond the last class. That's weird. Okay, but this is going to go from 60 to 100. The next one would be 110. So I'll put in 110. And our X scale. X scale is class width, which is 10. Y min, 0. So put 0 in. Y max, your guess. Now I left this pretty vague because you almost have to kind of guess. See how I don't have to guess here because I know that my highest one frequency-wise was 3, but you don't know that before you go into it. So you pick something, leave it as 10. And then it says graph button. So if I press the graph, I get here and I see, oh, that's way down there. So I can go back to my window. And my Y max, instead of doing as 10, I can change it to 5. And press graph. And I come back here and see, okay, well, it's still down a little bit. Let me change it to 6. So I go back to my window, go to Y max, put 6. Actually, 4 is what I'm thinking of. Because that was 5, wasn't it? So 4. Then press graph. And you see, okay, I see a little bit better of it now. Now, if you press trace, it'll put your cursor right here, and it'll tell you for this one, n is equal to 2, and it goes from 60 to max is less than 70. 60 less than 70 is 69. If I do my right arrow key, see how this is 70 and then max is less than 80? 70 is 79. And it also gives you the n. Here's n is 3, n is 2, and then n is 1. Now when you're all done creating that on the calculator, then you want to set your calculator back. So press Y equals. Plot 1's highlighted, so I do an up arrow, put my flashing cursor on plot 1 and push enter on it. Then down arrow. And push zoom and choose Z standard, 6.1. So I press 6. Okay, now that's a lot. That's actually the first time I ever created that with those instructions. Worked out pretty good, actually. Most of the times we just want to do a quick and dirty with a histogram. Now I definitely recommend for my class that if you're creating a histogram, use Excel. It is so easy. But on your TI3, TI4, if I want to create a quick and dirty, go enter your numbers in, go into Stat, go into Edit, put all your numbers in, then do your second y equals, do enter on 1. Okay, we want it on, so I press enter on that. Down arrow, right arrow over to the bar graph, make sure it's selected. And when you get that selected, then do zoom and up arrow. And I got a lot of extra junk here. You won't have all these unless you go in the newer ones. And we want to choose zoom stat. So when I choose that, it'll give me its best guess on what I want. So very nice. May not give you the class widths like you want, but it'll give you something decent. Now, just to make sure that that actually updated, let me press Stat, go into Edit. Let me change some numbers. I put 52 in here, 41. Okay, so we got smaller values. Okay, so I'm going to go back to second y equals, enter on plot 1, and everything's already set up, so perfect. So I press zoom, and I want to choose the 9th one, so zoom stat. That one. And again, it'll give us the bar graph based upon that. And if I press trace, it'll tell me that this goes from 41 to less than 55.75. You see the class width and the upper class and lower class may not be that nice now. Right arrow to that, right arrow here, and you see all the different values. Anyway, again, to clear it out, I press y equals. Very quick way to turn plot 1 off is you do an up arrow, press enter on it, and then down arrow. And then I choose zoom, and Z standard set it back to where it was. Anyway, that's how to create a histogram on your TI3, TI4. Okay, stem and leaf. I think I am. Use the digits to the left of the rightmost digit to form the stem. Each rightmost digit forms a leaf. Example 147 would have 14 as a stem and 7 as a leaf. Now these give you the steps, and you can refer to them. Stems are the digits to the left of the rightmost digit. Leaves are the rightmost digit. Write stems in vertical column in descending order, no duplicates. Write each leaf to the right of these vertical from smallest to largest. These can repeat. Well, let's create one of those. And actually, I guess I'm ready to save this page. Yes. Organizing. Quantitative. Data. Popular displays. Page 01. Okay, so we're going to create a stem and leaf. So I'm giving some data here. I got 91, 92, 92, 85, 83, 82, 82, 71, 73, 75. Now, excluding our rightmost digit, this what's left over here, we're going to put down in this column. From smallest to largest. So I got 7, 8, and 9. Then the rightmost digit is what we put in this column. Now here's, let me do the 70s first. 71, 73, and 75. So put 1, 3, 5. So going backwards, this would be 71, 73, 75. So give you that. Now for our 80s, we have 82, 82, 83, 85. So we've got 2, 2, 3, 5. So 2, 2, 3, 5. Now we don't repeat the values over on this side, but we do repeat them over here, our leaves. Now 90s, we got 1, 2, 2. So again, 91, 92, 92. This allows you to see the distribution of the data. You know, if it's a bell curve, more or less, if it's kind of uniform, could almost be considered uniform how high up these go. Then it says that the data is bunched up, can split into stem into 2 or more, can repeat. This is referred to split stem. So instead of having 7 here, I could have 7 and 7. And this first one would be 71 through 74. Try that again. Okay. And then our next 7 would be 75 through 79. So you split up into 2 separate pieces. There we go. Now a dot plot, you don't see these a whole lot, but place each observation horizontally and increase in order and place the dot above each observation each time it is observed. Well, going across here, first one you see 1 dot here, next one you see 2 dots, and 3 dots, and maybe this is down to 2 dots. This is real popular in exercise equipment. Beyond that, I don't think I've ever really seen graphs of that sort. Not real popular in business. And our last one, shape of a distribution. If we look at our bar graph, our histogram, or if we look at our stem and cell, then you can look at it and see how the data is arranged. Now, if it's straight across, that's uniform or symmetric. If it forms more or less a bell shape, that's symmetric. Now, the skewed right and skewed left, they're opposite what I'd think. When I'm looking at this skewed right example, it looks like to me all the data is on the left side. So that's skewed right. Now, in this one, the skewed left looks like all my data is on the right side. Or, did I say that right on this? All my data is on the left side here is skewed right. Over here, all my data is on the right side, and it's skewed left. So it's opposite of what you might think. I go to all the trouble to create a bar graph, histogram. And let's say this is what it looks like. Well, if I connect together the middle parts of them, like that, now form something like that, which is more or less bell-shaped. So that's how you can tell the shape of your distribution. Now, these aren't that easy to create by hand, but in Excel, they're very simple to create. So, again, get used to that, or worst case, create it in TI3, TI4. And that's the end of that section, so let me bring up the recorder. Stop that.